Hello, everyone. My name is Tom Oh. I'm a professor at the Strategic Initiative Innovation Director at the Rochester Institute of Technology. And I'll be talking to you about smart cane navigation for blind and visually impaired. This was the project I worked on a while back, several years ago. But this is somewhat related to shortest path algorithm. It was used in this, but I'm not going to get into the shortest path algorithm, but I'll be talking to you about the application part of it. Okay. So shortest path algorithm was used I mentioned in the lecture regarding using the networking. It could be used in other areas, the drone, the vehicle, and another one is navigation for the blind, visually impaired. Particularly, I'll be focusing on the indoor navigation. Okay, so my motivation was the purpose of life is not to be happy, it is to be useful, to be honorable, and to be compassionate, to have a time to make some differences. You lived and lived well. So I know all of you are, in a great university, you want to be very happy too. But sometimes it's not that only the doctor who can help. Technologists, you have a technology, you can provide assistive technology to people who are, have a physical disability, deaf and hard of hearing disability and visually impaired. It really can make their life different using technology. And this is what is it about, okay? So statistically, the blind and vision impaired, over 1.3 billion people have some form of vision impairment. Some of them was born blind. Some of them are, not all of them are born blind. And when you think about the blind and vision impaired, you think that they were blind initially, but a lot of cases, because of the accident happened during 20 to 30 and 40. And another thing is when you get really old, right, when you have a severe diabetic, you lose your vision too. So also, a lot of people lose vision through different disease. So there are 217 million people who has a moderate to severe vision impairment, and 36 millions are, totally blind. And when you think about it, for the assistive technology for them, it's very limited because companies and a lot of the companies out there, because even though it's a 1.3 billion people, it's a small number of people, small markets. So not many companies are investing their resources and effort into it because it's considered to be pretty small. When you look at the US statistics, severely blind to totally blind, to all ages, 7.6 million people are blind, 16 to 75, about 7.2 million people are blind. 3.9 are women, 3.2 are men. And 16 to 64, there are 4 million people are, blind, okay? And for the age 65 and older, 3 million. As you can see, it's higher compared to it's not quite half, but about 40% of that is 65 and older, because as you get older, you tend to have a disease, and if you're diabetic, you tend to lose vision. So that can be really difficult to get around. So we do have a white cane, and they're established and created by 1930. George Bowman created a white cane, and it's white. It's more visible, right? White cane is more visible, so they call it a standard. They create a standard called white cane, and cane has revolved, over the years. So there's a long cane, there's a guide cane, identification cane, support cane, kitty cane, and green cane. There are a lot of different types of cane. So cane support your body weight. That's more of a support cane. I mean, when you have some kind of leg surgery or something, you need a cane to support your body weight. Okay, so some of them have a hard time getting. So, but problem is that even though there are a lot of different types of cane, but only 2 to 8% use, white cane. But many of them don't use, you're thinking that how do they getting around, right? How do they getting around? Typically, they do get around. It's amazing to me how they able to navigate through subways and different places because when they walk through those, they've been through so many times, initially with, guide, but they have a different references, right? They know how many steps they need to take to get to the certain reference. And if you do that, so many times and, they're able to figure it out. The thing is, because they're blind, their hearing sensitivity is very, very high. Their other sensitivity is very high to accommodate what's lacking, okay? So, but still a lot of challenges, okay? Obstacles that are above knees are very challenging, like towards the head. There's nothing, or when you walk, protect your head, right? Because cane will just feel the front of the road, but in nothing upper body, and that's very challenging. And then also sudden drops, like stairs. It's very difficult to detect using Ycam. There's a lot of uh, uh, um, issues, and they came out with a lot of different cane, like here, ultra cane here. It has an ultrasonic sensor, detects objects, chairs, and something, and that this is more of an overhead. If there's branches or something that could hurt the person, you make the vibration. As you can see, there are two vibrations, upper one for the upper, low one for what's on the front. And how much do you think this will cost? Over here, Ultra cane over here. How much do you think it will cost? This one is a $1,200. Okay, $1,200. You can convert that into, what do you call it? Korean won, but $1,200 is a pretty expensive, right? And typically, people who are, who are disabled, their income generally tends to be lower than the non-disabled people. So, there's a smart cane from India. It detects the object in front of them. That's a smart cane, and so that's what the sensors are there. Okay, so it uses ultrasonic. What it does is sound. It sends the sound frequency. It senses the bouncing back of the frequency. It captures just that. It captures the delay and it calculates the distance. Okay. So problem is once it sends out and it doesn't come back, that becomes a problem. So that's one thing that is the challenges of so this is the latest version of a cane technology. This is a WeWalk. You can see the YouTube. You go to YouTube and type WeWalk. The WeWalk is connected to your phone, and you will provide GPS. You'll tell you, like you use your phone to, navigate using your car, right? Like a Google map or neighbor map, navigate. Same concept. So what WeWalk will connect to your phone, and you will provide navigation for walking. So one lacking thing, one challenging thing about this is that it's for the outdoor use. It does have a GPS. As you know, when you walk, when you drive around with your GPS, it's not really accurate, right? It tells you you're at the destination. When you look, you're not at accuracy, that location. You might have to go maybe 100 feet or 150 feet gets to the destination. But you cannot have that in this case, right? Because they're totally blind, cannot see. When you indicate they're at the destination, the accuracy level is somewhat lacking. So that is a big issue. Okay. So a lot of previous work on obstacle notification for smart cane, and there's a voice alert in 2011. speakers worn out the user's chest, put it on the chest, to give, it makes a sound if there's something in front of them. Also, the 2001 servo motor steers away. If there's a servo motor here, it tells the user to, move away, pulling away, those kind of things. The cane attachment with the haptic cue is 2012. It has been around for pretty some time, but so none of those being commercialized. A lot of those are more of the research focused. Okay. So commercial smart cane product issues not widely adopted by the people. It's very expensive, and there are a lot of technology limitation. It's a high price, ineffective for user interface. It's a less than 1% used for any form of a smart cane. So it's not being used. So I was wondering why it's not being used. I mean, there could be a lot of different problems. There could be a user interface problem. There are other issues. So overall goal for intelligent mobility cane that what I worked on is indoor navigation. For the outdoor navigation, like a WeWalk, that is for the outdoor, but we don't have much for the indoor, right? So indoor, what I was focusing on, the more of the public place, like a workplace, a university, airport, the museum, small subway station, public library. Those are the location that we should be, focusing on. And for the intelligent navigation, consider people, traffic, subway, plane, schedule when and walking route is selected. The smart intelligent came for the offside. When I'm talking about is offside and also the indoor, we're not focusing offside, okay? Just focusing indoor. There's people traffic when you get the subway underneath, like if you're at the airport, walking around selected. It's dynamically adjusted based on people's traffic and haptic notification of delivering walking direction for the user. Um, uh, go to left, go to right, whatever it needs to go. If provide walking direction user is very important. There's obstacle detection, detect static, moving objects, and you people are using ultrasonic sensors. Okay. So objectives, so my objective, intelligent navigation system for indoor environment is very, very important because when they go to the mall, for example, right, mall, there's no way for them to figure it out. There's so many stores, right? So how can they go from one location to another location unless there's a person really guiding him or her to the store, okay? So number two is explore different user interface for haptic vibration notification. On the cane handler, provide understandable notification of upcoming obstacle for indoor environment. For obstacle detection, front detection, obstacle overhead, side drop detection, navigation stop, right, left, straight, all the functions are the future work, okay? So overall navigation system for smart cane look like this because the brain part of it is, it's in the cloud, AWS cloud. It does machine learning, pathfinder. It can be the shortest path algorithm could be applied because a smartphone can do so much. It's somewhat limited, right? And also smartphone, you're running, I'm sure all of you have a smartphone, Android, a Galaxy. All of you are running some form of application. Even though you're not talking or anything, but in the background, there are a lot of applications are running to keep up with your locations or whatever you need. Like if you need a restaurant recommendation, you app kind of keep up where you are always, if you set it to always. So there are a lot of background, processing is occurring. So it's not possible to have all the, thinking, the processing on your phone. Then your phone get really hot, then you will drain your battery pretty quickly. So instead of doing that, sending whatever the information to collect from a smart cane, send it to the cloud, and you process and send it back. And this is the brain part of it. You send it back with the instruction. The phone will communicate using Bluetooth for the direction for the notification, okay? So AWS Cloud based on machine learning solution inputs are there. The map of the facility, hallway, floor. We got this from the, we tested in our college facility in the map of facility rooms, hallway, and floor. Those are the inputs. And those are the inputs. Which rooms, hallway, which floor, second floor, first floor. Then also the localization Wi-Fi sensor device. Estimo, we use the Estimo, this device here for location, deciding where they are. And the input is a RT building schedule, student traffics. We need to know those, when the classes will be over. But in this case, we were not really applying this. We were just looking at the more shortest path. And tools or any AWS Juniper notebook also provide walking route with the least human traffic. Okay. So previous work on the obstacle notification for SmartCane, I think I'll mention this. I'm sorry, this is a duplicate FTQ. I think I mentioned this previously. I'm going to skip this. The research focus is next thing is I'll talk to you about the navigation indoor, right? There, what are the components and needs, and gave you the overall architecture of it. But we need to explore the haptic vibration notification system on the cane handle to provide understandable notification of upcoming obstacle or indoor environment. What does it mean is if there's an obstacle, you need to notify the user, go to left, go to right to go around it, right? So obstacle detection is a front obstacle. There's an overhead for anything tree, not the tree branches, it's something overhanging. And the side drop detection, we don't want them to go off the side or fall off the stairs, right? So for navigation, stop, right, left, straight, although all of those are future work, but we did able to make some progress on that. Okay, I'll share that with you. So intelligent mobility cane, this is a more the initial version of the prototype we used. Is that front feedback here, and there's Arduino Uno mobility cane, front ultrasonic. There's overhead detection. One of it is overhead detection indication, and there's all the front indication. Very simple cane. So over the years, we have modified the implementation. As you can see here, this is Arduino Uno. There's a top of the cane vibration. We use a vibration motor to indicate whether it's a front or overhead detection. And also later on, we have implemented more of a navigation side. And we have, developed different types of message delivery method. There's a 2 button here, overhead button here. Overhead button is something's overhead. Left button is go to left. This is button means go to right. So when you're actually holding it, you will feel the vibration, and you move according to the direction is what is providing. On the right side, this is one of the another type of it's not a vibration. This things moves up and down. Okay, ups and down. And there's another one on the other side. We did countless interviews. Some of them, a lot of them actually want to move away from the vibration, and they prefer to have some form of, different alternative type of notification. So we did a lot of investigation on it. It's something that's rubbing on your inside your hand. So this device moves up and down, okay? So for usability study, we worked with the Association of Blind and Visually Impaired, ABBI. ABBI has over 700 employees. All the employees, not all, majorities, 90% of the employees are blind with the low vision and served, 150,000 people yearly. So they basically get funding, or what do you call it, a contract from the government to, they have a manufacturing facility, contract from government. For example, putting the patch on the head, putting patch on the, side of the uniform, things like that. They get all of those bidding and, provide job for over 700 employees. So we interviewed with the different types of participants. There's a female, male. Some of them have used the cane for 24 years. Especially this person, he goes around everywhere using the cane and look like he's not even blind at all. So he's very proficient in audio, hearing, and also the cane usage. Some of them are, use the cane for 40 years, since 3 years old. It's all different types. For example, here, age 54, he used the cane for only 10 years. And when he was in 40s and he was able to walk around. So there are a lot of different cases. Here's the age 62, he used the cane for only 3 years. Before that, he had a great vision before that. So there are a lot of different what do you call it, the cases of blind and low vision. There's no one case. So some of them are totally blind, a lot of them are low vision, but they can see, what do you call it, not clearly, right? Those kind of things. So we did a pre-interview, ask questions, holding the technique about how came, why we're doing this study. And we also explained the international mobility obstacle path description about that, and also usability testing for headsets. Okay, we talk about that too. In the post interviews, after the interview, and after they go through the, you know, uh, you know, experiment, they talk about how was their experience. So we create a path, something like that. Like it's in a huge conference room here. We put the trash can as an obstacle. We asked them to go around. We did not ask them if it's around, but we asked them to walk. So they have to avoid the chairs on the side, trash can, and they have to avoid the kitchen countertop here. They have to go around, they have to go around, get to the, final destination here. So typically, we provide understandable notification for intelligent mobile cane. A number of participants, here's the evaluation results. So they felt that, out of 10, 10 out of 10 detect the obstacle in the various places. That seems to be went well. But the 8 out of 10 provide a clear, accurate notification, and the 2 did not feel that this was working properly. Okay. About 60% of it felt is a very distinct vibration, was really strong. It was really good. And vibration in project outward, and the vibrator project outward, which it means is it was working properly, but they did not like the vibration at all. They really have interested in some other form of notification. And about 60% of felt that the learning curve was has to be there. They never used anything something like this. So learning curve was pretty steep. Okay. So beacon was used for navigation here. Is iBeacon is Apple technology standard, works with a mobile phone. Listen to signal from the beacon, react. Beacon basically acting as a reference point, okay? We use SD mode, is a, in Bluetooth beacon here. So you place the beacon along the path. So what happened is once the cane using smartphone, which is that reference point, you look for another reference point to be reached. So you will go toward the next reference point. After that, you reach the next reference point, you will seek another reference point. Using following the path is keep finding the reference point to get there, one after another. Pretty soon it expects that you will get to the destination. It's a small computer, has a little bit of CPU, flash memory, it has accelerometer, temperature sensor, and this is the reference point for the navigation part of it. We use an indoor, you know, software. Is navigation technology user. Is a proximate. That really narrows down the accuracy pretty good. Offline map localization, battery saving, variety of map routing, geofencing, floor building transition. They do all of those. So we were using this software to provide navigation. There are other types of beacon solutions, Gbo, Kataki, and Swirl, Sonic, and there's indoor. This is what we picked. MobiQuit. There are other solutions. We have explored all of it, and indoor provide a free service to us, and it was fairly accommodating because using Apple products. So that's why we picked the indoor, but you can explore other form of beacon solution and use it, okay? For the indoor navigation is an important part of the technology which has evolved over time. GPS technology used in navigations as a vehicle, but GPS does not work in the indoor. There are a variety of technologies we use. One such technology is indoor, like I indicated here. MMT is a tool they use to set up the building map. What it does is we do have a PDF version of the map. You will receive the map, create a digital map out of it. Then it understands where the location of the classrooms, where are the doors and things like that using the map. So tool can set up a floor, beacons, and the zone. After setup is complete, setup configuration save in the cloud. This is the cloud does the most of the what do you call it? Thinking, processing, and cloud send the results to the mobile phone. Mobile phone just deliver the result to the smart cane. You can tell the smart cane to go to left, go to right, ultimately, and the user using it that is being helped to move around efficiently. Okay, so this is the beacons, and we used like there's another beacon user has a Q code, and the implementations was Android, iPhone can be developed. At the time, we have started using the tool. Map help us to navigate inside the. So what we did was that this is the map of the second floor, and we have implemented those different the beacon in this locations, and we have created a map, app. I'm sorry, create an app. We like this, the indoor app. So you can't see it, but this is for the demo. So where do you want to go? And you pick a location A to B. Get routes that you provide the route, something like that. So basically it uses the shortest path algorithm in this case, but we're not considering all the traffic when the class is over. We're not considering a lot of the schedule. Then in that case, we may have to use AI, but the shortest path algorithm is when it went perfectly fine. So we did some experiment. It did work well. And we were just expanding that the pandemic came, okay? So it can be used for negative indoor independently. Best use case is this is integrating indoor navigation with the intelligent mobility cane, which can help blind people navigate inside of the building, okay? This is my lecture for today. This is what I wanted to share that with you because I'm not really focused on explaining how shortest path algorithms are being used here because I thought you that in the separate lecture, but this is more of an application side of it. So in this case, it's an indoor use the sources path. We have not included class schedules and any of the other upside parameters in there. In that case, and when it becomes more complex, then we have to use AI machine learning to do that. But just having a shortest path algorithm with the indoor, it was it was good. It was effective, and it was an interesting project. After this, the pandemic came and everything was stopped after that. So I hope that this lecture is interesting to you. Remember, you're at the great university, and your valuable knowledge in technology can really help others, especially people who are disabled. Okay? All right, let's see. Okay. Okay, thanks for listening, and I hope you have a wonderful day. Okay? Bye.